Good morning, ma'am. Myself, Shravanti. My topic is about problem solving with recursion. Firstly, we need to know what is recursion. Recursion is a program technique where a function calls itself to solve a problem. Uh, recursion is in a program. Recursion function calls itself to solve again and again to solve a problem. Here, it's a diagrammatical form. The recursion is shown. Firstly, we are declaring the function. So defining the function def recursive, again the recursive function will be calling itself again. So the recurse function will be calling itself again. So the recursion function will be calling itself again and again until the problem is solved. Usage. Why we are using the recursion function means particularly useful for problems that can be broken down into smaller subproblems, similar subproblems. It is used for to broken down these complex problems into smaller subproblems because that will be solved that can be solved easily when compared to the complex problems which are divided into subproblems. So the n, if n equals to 0, then n factorial will be 1. If n is greater than 0, then n factorial will be 1 into 2 into 3 into so on into n. If n equals to 0 or n equals to 1, the n factorial will be 1 only. Example problem factorial calculation. These are the three conditions we should keep in mind when we are dealing with the recursion functions or recursions. Base case, recursive case, implementation. Base case is nothing but factorial of n or 1 is 1. We should all know that factorial of 0 or 1 is 1 only. So the recursive case, this is nothing but the formula of the factorial to calculate the factorial of a number. N factorial equals to n into n minus 1 factorial. Here we can take an example of factorial of uh, 5. Example of 5. 5 factorial equals to 5 into 5 minus 1 will be 4. So 5 factorial equals to 5 into 4 factorial. So 5 into 4 factorial will be 120 factorial. So same like that, all the numbers should be calculated. Again, implementation, Python function using recursion. Here is a simple program to calculate factorial of a number using recursion. Firstly, we are uh, defining the main function, and after that, number equals to int input, enter any non-negative integer. Here, we are taking the input from the user. In this step, we are taking the input from the user, and again, fact equals to factorial of a number. This should be calculated. Print, we are writing the printing statement. Factorial of number is fact, means the factorial of will be enclosed within the single quotes, so this will be printed in the output. Here number is not for the number is not having the single quotations, so it is a value of the above number. So the input will be taken from the user will be displayed here. Is a in the single quotation, so this will be printed in the output. Fact is the value that this can be stored, that will be displayed here. Again, we are defining the another function called factorial of num. If num equals to 1, then it will return 1. Else it returns num into factorial of num minus 1. Means this is the formula of factorial. And again we are calling the main function. So the output will be enter a non-negative integer. So the user entered here is 4, and the factorial of 4 is 24. This is a clear explanation about how the factorial will be working. These three are the recursive steps and this will be the base case. So 5 factorial equals to 5 into 4 factorial. We can write 4 factorial as 4 into 3 into 2 into 1. We can also write in that manner also. So 5 into 4 into 3 into 2 into 1 will be the we will get the value as 120. So 4 factorial will be 4 into 3 into 2 into 1 will be 24. 3 factorial will be 3 into 2 3 into 2 into 1 will be 6 factorial. And again 2 factorial will be 2. That is 2 into 1 will be anyways 2 only. Now we should know about the direct and indirect recursion. Direct recursion is nothing but recursive functions or functions that directly call themselves. This is known as direct recursion. Uh, di- just now we saw an example of a program that calls the function at the last itself only. So this is the direct recursion. The function calls itself is known as direct recursion. Indirect recursion is nothing but it occurs when a function A calls function B and which in turn calls function A. This is in the circular manner. So this will be the indirect recursion. These are the differences between the direct and indirect recursion. First, the basis comparison, direct recursion and the indirect recursion. Mode of handling base or recursive case. The base case and recursion case are defined within the same function only. Here, both are declared within the same function only. In indirect recursion, the base case and the recursion case will be in the separate functions within the function. This will be within the function and indirect will be the separate functions. Initiation of recursion means initialization of recursion. Recursion is initialized by the function calling itself directly. Here directly the function calls within the body. uh, Indirect recursion means recursion is initiated by one function calling another function, which in turn call another function first. This will be the indirect function calls. Advantage: simplicity and efficiency. The code of the indirect recursion will be simple and efficiency. Here, modularity case of debugging means debugging is complex. Here, the debugging is complex. Advantages of using recursion. A complicated function can be split down into smaller subproblems utilizing recursion. By using the recursion, the complex problems will be broken down into smaller subproblems. The smaller subproblems can be solved easily. By using the recursion, we can find the solution in a efficient manner, in a simple manner. Sequence creation in simple though recursion that than utilizing any nested iteration. Recursive function render the code look simple and efficient. The code of the recursive programs is they look simple and they are efficient. Disadvantages of recursion: expensive. A lot of memory and time is taken through recursive calls, which makes it expensive for use. Challenging to debug means recursive functions are challenging to debug. The tough to think means the reason behind the recursion can sometimes be tough to think. Base case is nothing but it will always defines a base case that directly provides the solution for the smallest possible input. Without any base case, the recursion will be continue indefinitely, leading to a stack overflow or an error. Then the recursive step. It ensures that the recursive calls make progress towards the base case. In the factorial example, we reduce n by 1 in each recursive call until it reaches the base case. Correctness means it ensures that the recursive function correctly solves the problems for all valid inputs. Efficiency. It sometimes recursion can be less efficient than iterative solutions due to the overhead of function call and the stack operations. We are coming to the conclusion. It can easily be concluded that recursive functions are most important for solving mathematical problems that requires a similar method or logic to be implemented repeatedly until an exit condition is met. Recursion is used for solving the functions which are solving the mathematical functions or solving the any problems which are complex problems that are divided into smaller subproblems, and then the output will be generated automatically. Recursion often leads to code that is easier to write, understand, and analyze formally. The recursive function program is easy to write, and it is easy to understand also. In some cases, recursion can be less efficient. More function calls and stack operations are more, because so that's why the efficient will be less. To make recursion more efficient, then the function calls and the stack operation should be less. If they are less, the efficient will be more. So this is the end of my topic. Thank you.